All right, 5.2. Talking about perpendicular bisectors today. You should know what the word perpendicular means. That obviously means you are intersecting at a right angle. And a bisector cuts something in half. Now the formal definition for a perpendicular bisector is that it's a segment, ray, line, or plane that is perpendicular to a segment at the midpoint. Okay? Midpoint because it's being bisected. So here we would say that line CP is the perpendicular bisector of segment AB because it's perpendicular to AB and it also bisects segment AB. So that's your definition for a perpendicular bisector. Several theorems today. Here are the first two. First one's your perpendicular bisector theorem. It says if the point is on the perpendicular bisector of a segment. So if you have any point on your perpendicular bisector, then it's going to be equidistant, meaning equal distance, from the endpoints of the segment. So any point on this line is going to be equidistant to A and B. So for example, here our point is C. That means that this segment and this segment would be congruent. Perpendicular bisector converse says in a plane if a point is equidistant. So if you have a point, I'll draw an example here. So in a plane, if a point is equidistant from the endpoints of a segment. So if I have a segment, we'll call it AB. If our point, so let's call it point R, if this point is equidistant to the ends of the segment, then it means it's on the perpendicular bisector. So if you drew the perpendicular bisector, it would go through that point, is what that one's saying. So in other words, any point on a perpendicular bisector is going to be equidistant to the endpoints of the segment. Next we have what we call as concurrency. So concurrency is when three or more lines, rays, or segments intersect at a point. So, for example, those three lines would be concurrent. Okay? Three or more lines, and they all intersect at the same point. So we call those concurrent. This point right here, we would call the point of concurrency. So just some definitions there. So how that works with our theorem, concurrency of perpendicular bisectors. As you see, we have a triangle. It says the perpendicular bisectors of a triangle. So our perpendicular bisectors are in blue. They're perpendicular to each side, and they also bisect each one, dash, dash, 3 and 3, 2 and 2. So those perpendicular bisectors will always be concurrent. They'll meet at a point, and that point is going to be equidistant to each vertex of the triangle. So it's equidistant to D, C, and B. So those three dotted green lines would all be congruent. So some quick examples. Just find the length of AB. Now, again, a lot of times in geometry, you just go, hey, let's set them equal. Which a lot of times is true, but then you're not going to quite understand why. And understanding why helps you with things like proofs. So finding the length of segment AB. Well, you should be able to look at this picture and say, hey, well, this is a perpendicular bisector. We have a right angle, and we have two congruent chunks here. Which means that perpendicular bisector theorem says if a point is on your perpendicular bisector, which B is, then it's equidistant to the two endpoints. So that's the reason why 7x plus, or not plus, my bad, 7x equals 4x plus 24. So obviously you subtract, and x is 8. The next example here, you should notice that you have perpendicular bisectors. Okay, here's one here, here's one here, there's perpendicular bisector there. They're the ones that are perpendicular, and they're bisecting. So now we have several lengths that we need to find. First says AG. So if you look at AG, that is this segment right here. Well, the way you figure that out is you look over here. Okay, this point is on a perpendicular bisector. So that means that this guy and this guy are the same. So GC is 25, which means AG is also 25. Then we go to GF. This you maybe don't remember how to find. But if you don't, we have a right triangle. Hopefully at some point you remember learning Pythagorean theorem. So Pythagorean theorem, remember a squared plus b squared equals c squared. C is always your hypotenuse, that's 25. So 24 squared plus, let's call that x. X squared equals 25 squared. So that means that 576 plus x squared is 625. Subtract x squared would be 49. And square root of 49 is 7. Then we look at DG. Well, we also get a right angle here. So it's another Pythagorean theorem. We'll call it y this time. A squared plus b squared equals the hypotenuse squared, which again is 25. So 20 squared plus y squared equals 25 squared. So that's 400. Y squared would be 225. And square root of 225 is 15. EC, that should be pretty obvious. It shows you that EC is the same as this one, so 15. GE, gonna have to use Pythagorean theorem once again. So we said this was 15. So then to find GE, we're gonna have, let's call this Z. GE will be Z. So Z squared plus 15 squared equals 25 squared. Which you're going to get Z squared equals 225. So that one is going to be 15. Unless I made a mistake, which I feel like I did. Yes, I did. I lied. So what happens when I try to do too much math in my head. So we'll write it out this time. 225, that's 625. So z squared is 400. Then the square root of that is 20. Finally, AC goes here to here. Well, if this is 24, that's 24. So we get 48. So, perpendicular bisector, main takeaways, is that a perpendicular bisector, any point on there is equidistant to the two endpoints. And remember that a perpendicular bisector intersects a segment at a right angle at the midpoint, so that these two are the same. Those are the main takeaways. Also, you're going to be doing some Pythagorean theorem today as well. And yes, there's a proof on this one. Yay!